Okay, we go on to problem number 3. I'm not going to explain the whole problem. I'm sure you've all read it, or if not, take the time to read it now. We have two fields, and we have a square field and we have a rectangular field. And later on we're told that x is going to be the width of the rectangular field, so let's start from that. And we're told that it's twice as long as it is wide. And we know we have a square also that is not necessarily related to x, so we're going to call that y. Alright, a couple of things that we do know is that the square field must be at least 100 square yards. So we say y squared is greater than or equal to 100, and the rectangular field must contain at least 800 square yards. And so we can say 2x squared is greater than or equal to 800. Alright, so those are the basic scenario there. We can talk about the total perimeter, which we know has to add up to 340. So we can say that 6x plus 4y is equal to 340, and the area, the total area, is going to be 2x squared plus y squared. And that's what we're going to try to maximize later on. And we're going to use the information from the perimeter to swap out one of our variables, rewrite the area in terms of x or y, and then we're going to find its derivative and find where it's going to be maximized there. There's a couple of very tricky points with this particular problem, so we have to pay close attention. The first question asks if x is the width of the rectangular field, and what are the maximum and minimum possible values of x. Well, the maximum value of x will be when y is at its minimum. Y is at its minimum when y is equal to 100. So when y is equal to 10, then the perimeter of the square is 40, and that leaves 300 yards of fencing for the rectangular field. And in that case, x will equal 50. Now for the minimum value of x, we want to let 2x squared equal 800. And that happens when x is equal to 20. 2x squared is equal to 800, x squared is equal to 400, x is equal to 20. So stated another way, we can say that x has to be between 20 and 50 yards. And the fact that we have a closed interval here is very significant because we're going to have to test the endpoints when we get into the finding the maximum value for the total area of the 2 yards of the two fields. Now when x is equal to 20, that's going to give a perimeter of 6 times 20, which is 120 for the rectangular field, and 340 minus 120 leaves 220 for the square field. And so y has a maximum value of 55. So whether we state this in terms of x is going to vary between 20 and 50, and y is going to vary between 10 and 55. Now the y wasn't asked there, just the x's were, and so the answers are 50 and 20 for part A. Now we're trying to find the greatest number of square yards. Now we know that the area in terms of x and y is 2x squared plus y squared. And I am going to solve for x, solve for y, and solve for x here. And when I do that, 6x plus 4y is 340. Subtracting 4y from both sides leaves me 6x equals 340 minus 4y. So x is equal to 340 over 6. Now that's okay, but it's not as nice as if I had solved for y in this case. And if we had solved for y, we would have gotten 85 minus 3x over 2, and that's what I'm going to use. And when I substitute in, I get 2x squared. Area only in terms of x is 2x squared plus the quantity 85 minus 3x over 2 quantity squared. And we'll start from there in the next video.